Welcome back. We are excited to have you here for the next iteration in the ESAPI Foundations course series, this one titled Pathway to Application Development. And you should be excited as well, because at this point in your ESAPI journey, you have already learned some C# programming. You've already learned how to build scripts with the Eclipse Scripting API, and what we want to do going forward is we want to improve on those skills and be able to build applications that our clinicians will use and appreciate. In this course, we are going to describe the basics of software application development. We're also going to prepare you for the application development with ESAPI course so that you'll have the background and the terminology ready to take the course. A bit of an overview before we start this course. We're going to first talk about the difference between basic scripting and software development. We're going to talk about the basics of model, view, view model, pattern framework. We're going to do a quick demo to demonstrate the difference between an application that you maybe have been building up to this point and the applications that you can build moving forward. We'll dig into the concept of properties and why sometimes your user interface doesn't update the way you expect when properties change. And finally, we'll focus on a demonstration of this by building a reactive user interface with a model, a view, and a view model. Up to this point, you may have already been writing some scripts, and you may have already been creating user interfaces. Generally, the user interfaces that you might have been creating so far may be simple user interfaces showing data or allowing the user some basic interactions. The issue here with these types of scripts is that they can be difficult to scale and add new features and new components. When you're building software for your clinic, your users generally would like to have reliable software that responds quickly and reliably to their user inputs. The user interfaces should be intuitive, and you want to try to mirror similar behavior among different apps. As a software developer, you want to build code that's reusable, testable, and easy to debug. The model view view model pattern framework is an architecture that was built for this exact reason. In this pattern, you can build reliable software that you can deliver to your clinical users. Consider the following app. You build a simple app that you're very happy with, and this app shows you some dose prescription data. And this simple app is made up of a single user interface file. And in the code behind for the user interface file, you're taking the information from the Eclipse Scripting API and making some modifications and massaging it for your application. Everybody's happy with the application, and as a developer, you're also happy with how this application works. As the application begins to grow in scope and users start to ask for new features, the app will continue to grow, and if this is still one single user interface file and one single code behind file, the code will start to get a little bit long. No problem, you'll just have to scroll through and find different sections of code that change different properties. And any updates that you make to that code, it may just take a minute in order to remind yourself of where certain methods and certain properties are located. Then as the application continues to grow, the code may become unmanageable. You can imagine this as a very long, sometimes we call them God methods, where you have so much code in one single file, it becomes very difficult to figure out what part of the code might be misbehaving at a given time or what part of the code you'd want to update. Building software using the MVVM pattern allows you to scaffold your project as multiple files and multiple classes. The idea behind model, view, view model, pattern building is that your user interfaces are independent of the C# code that we commonly refer to as a view model. The UI and the view model will communicate through a concept of binding, which we'll see in the next PowerPoint. This allows you to decouple the user interface from the logic. It allows you to separately test the logic of the code without requiring the user interface and make modifications to the user interface without fear of updating or making some mistake in the view model C# code. One benefit that gets overlooked to model, view, view model, pattern applications is that if you're following this MVVM style of application development, you're welcome to continue to use open source code that also follows the MVVM pattern. It makes it very easy to plug and play with open source code bases. Let's continue building on our knowledge of model, view, view model, pattern applications with some more slides and definitions in the MVVM software development world. Before we begin with some hands-on demonstrations, let's first get a couple of definitions around the MVVM software development pattern. Here we're going to talk specifically about binding and data context in MVVM. What you may be used to when building applications that have a user interface is looking at code like we see on the left side of the screen. Here we have a text block, and in the text block we have set the name of the text block to my text block. Then in the code behind file we can access the text block by the name, as WPF gives us access to each of these user interface elements as if they were properties of the class. Then we can set attributes of this text block, for instance. Here we're setting the text to hello world, and this is probably a pretty familiar type of software development that you may be used to. In MVVM application development, we're going to change this behavior just slightly. Instead of giving the text block a name, we're not going to name the text block and access that text block from the C# code. Instead, we're going to focus on the actual attribute that we're trying to change about that text block. So if we want to change the attribute for text, what we're going to do is we're going to use this binding keyword, which is wrapped in these curly braces, and we're going to put the name of the property that we want to be evaluated to determine the value of this attribute after the binding keyword. So here you can see text equals an open curly brace, the binding keyword, and then a space, and then the name of the property that you want the application to go and evaluate to set the text of this text block. In the C# code, you can see the basic property greeting is created in a separate class, and here we're setting the greeting equal to hello world in the constructor of that class. Let's break down this binding expression a little bit more. So here you can see the text block with just the simple binding expression. The idea here is that whatever comes after the binding expression is the name of a property, and that property will have a value of what you want to see in that attribute. But it doesn't just have to be the text attribute. You can also set binding expressions for controlling the way that user interface elements look, like the height and the width, or the visibility of a user interface element can also be set to a binding expression, allowing the property states here to dynamically impact the user interface in a number of different ways. We've discussed how we can have a binding expression and how that binding expression will point to a property and how that property's value will be seen by the user interface. But how does the property know where to look in order to evaluate that property? Well, the user interface is going to look at the property in the class that's defined by the data context. So somewhere in the application, we have to set the data context of the user interface class to the class where we want the property bindings to be evaluated. Here in this example, you can see that in the view class, so this is the class with the user interface, the main window class, you can see that the data context property is set to the myViewModel class, meaning that the greeting property in the myViewModel class will be evaluated because the greeting property is set in the user interface. Think about these as follows. The binding expression is the what. What is the property that I want to read for the value of any given attribute? Data on that property can automatically change the property value and update the user interface. Alternatively, data context is the where. Where should the user interface look for a given property? In order to help understand this a little bit further, let's do a hands-on demonstration to show the differences between applications that are built with this binding structure and applications that are not. For this example, you will not need Eclipse installed on the computer if you're following along. If you're following along, all you'll need is Visual Studio. In this first example, let's take a look at an application with a user interface that you might be familiar with if you're not currently doing MVVM. Here in Visual Studio, we're going to create a new project, and the type of project we're going to look for is a WPF, or Windows Presentation Foundation application. In keeping with the similar type of application that ESAPI is familiar with, we're going to choose the WPF app that has the .NET framework in parentheses, and also be sure to choose the C# WPF app if you want to follow along with this example. I'm going to slightly rename this project to have no MVVM at the end of it, just because we're going to compare this to an MVVM app, and it'll help differentiate one from the other. I'm going to save this right in my local users source repos folder and create a new folder here for this specific project. But you can save this anywhere on your PC that you can come back to. Let's go ahead and create the application. In creating a WPF application, you may be familiar with the template that Visual Studio provides for the application. This template will have a single user interface window file, and it usually names this one main window, and you can see the main window opens by default here. In the main window, we're just going to create a couple of very simple user interface elements. So the way we want this application to behave is, first, we want to create a combo box, and then based on the selection of that combo box, we want to update a text block to share a value as expressed by the combo box. So again, we're not using MVVM for this. So when I create the combo box, I can explicitly state a height and a width, and you can see the combo box is created here if I zoom in a little bit. And I'm also going to create a text block, and for this text block, I don't want the text block to be right on top of the combo box, so I'm going to move the text block to the top of the user interface, so it'll be centered here right at the top. Now, in this non-MVVM pattern, we can give the combo box and the text block name attributes, and those name attributes are how we're going to be able to access these objects from the code behind. So for the combo box, I'm going to give it a name of my combo box, and for the text block, similarly, I will give the text block a name of my text block. Now, to interact with these user interface elements, we can go to the code behind file. So if we want the combo box to perform some action, when we change the combo box setting, we can just double click on the combo box, and that will create a selection changed event for us. So we're going to be using events here to perform some action when the user changes a value. So in the constructor, we can go ahead and set the values that are available to our combo box. So we'll put this right under the initialize component method. We'll just add some text to the combo box. We'll add patient 1, patient 2, and patient 3, and then when the my combo box selection changed event is triggered, we want to change the text block text attribute to match the name of the patient that was selected by the combo box. Okay, so we're going to access that text block from the name that we provided to the text block, and then I will just set the text attribute of that name to the selected item, and of course the selected item could be a string, it could also not be a string, so we're just going to say toString since we're adding strings in here. And this is the way that the application will look in its first run. So let's go ahead and click start, and let's see how this application works. It's actually very simple. Like I said, so when we open the user interface, we'll see our combo box. We can see all 3 patients in our combo box, and when we select a patient, we should see the text block update at the top automatically. Here we see patient 2, patient 1, and you can see as I change the selection for each patient, the UI responds appropriately. For this next example, we're going to use MVVM to build the same application with the same types of features. So we're going to choose the same project template from Visual Studio, so nothing's going to change there. I can just select it from my most recent projects, and the only difference here is instead of changing the project name to no MVVM, I'll change it to say MVVM, and I'll just put it in a separate folder right next to my no MVVM project folder so we can kind of compare these back and forth. When I create the project, it'll look identical to the project that we created in the last example because the template is the same between the two. We're going to start with the same main window user interface, and we're going to build the same user interface elements. So just exactly the same way as it worked before, inside of this grid, we're going to create both a combo box and a text block. The primary difference that you should note here is that we are not going to set the name for either of these user interface elements. We will not be accessing user interface elements from inside of C# code. Remember that one of the key benefits here is the separation of concerns that MVVM allows us. So now we've got a combo box and a text block in here, and let's actually compare the way this looks to the non-MVVM application that we had before. So I'm going to just kind of drag this window over and share the screen with the Visual Studio window from the prior application that we built. And we'll just open up the user interface for both of them and kind of minimize all the empty space to just show just the XAML code in each one. And so in the non-MVVM application, we use the name attributes, but there are specific attributes that we're trying to target here. And for the combo box, the items source attribute is the attribute that holds the collection of items that you put in, and the selected item attribute, I'm going to change here to a binding expression with selected patient. That's going to represent the selected item itself. In the text block, we want to change the text attribute, and I'll put the same binding expression for selected patient. Now notice that the binding expression for the text block is the same as the selected item binding expression for the combo box. This is not by accident. Because we're going to put simple strings in this first example into the combo box, we can actually bind the same property between the combo box and the text block. So just take a look at these binding expressions here, and we'll maximize the window so you can see the whole thing. And now we've got our 3 binding expressions to help us control the way this user interface behaves. Now, to set these properties, to create these properties, we're going to use a separate C# class called a view model. And I'm going to right click on the project and say add class, and add a class called main view model. I generally make these view models public so that there's really no question about whether or not the view can read the properties in those view models. And using our code snippet CTOR tab, we can create a constructor. Inside of that constructor, we can set our defaults for our properties. So we're going to have 2 properties, as you could see from the binding expressions. We had 3 binding expressions, but 2 of them were the same property. One will be a list of strings, and then we'll call that property patients. And the other one will be a string, and I'm going to use my prop tab snippet to add that. And this string will be called selected patient. Now, just to set the default, we're going to set a couple values here in our patients collection. And so to add to any list, we're going to kind of do this, just instantiate the list right inside of this constructor. I'll say patients equals new list of string. And in squiggly braces, I can just put a bunch of strings in here. I'll just do the same thing I had before, which was patient 1, patient 2, and patient 3. But notice that I'm not using any access. I'm not accessing any user interface elements from the C# code. So we do have full separation between the user interface file and the view model C# code file. But notice I'm not getting anything in my combo box. Why is that? If you remember from the past PowerPoint slide, we also need to set the data context so the user interface knows where to look for those properties. So in the code behind file for the user interface, I'm going to say this.dataContext equals new main view model. And now when those binding expressions are evaluated by the view, you'll see that it looks in the main view model class for evaluating those properties, right? So if I have my patient's property, it's going to look in the main view model class for that. So let's dive a little bit deeper into some MVVM concepts. Because the binding expression depends so much on the settings of these properties that we're binding to, let's explore a little bit about properties and understand a little bit more about how they behave. The basic concept behind properties is that they expose data fields that allows controlled access to their values. MVVM relies on properties for binding to the UI. in the MVVM pattern, we're generally not going to have any named UI components in the C# code based on our clear separation of concerns. So our properties are going to be the gateways for how we access data. When we created a property in the last example, the way we created the property was called an auto-implemented property. This is an example of an auto-implemented property that you see here. I'd like to focus just for a moment on the end of this line of code in this property. You notice that there's a little piece of code here that says get semicolon set semicolon. These are referred to as accessors. The basic behavior of these accessors is that if you try to retrieve the value of a property, the get accessor is going to be invoked, and if you want to set or modify the value of a property, the set accessor is going to be invoked. Why am I mentioning this? Well, let's take a look at what full properties look like. When we're looking at full properties, you might see something that looks like the code snippet on the right. As a matter of fact, when you create auto-implemented properties like in the prior slide, the compiler is going to create these full properties automatically with these backing fields. You can see the private string backing field at the very top of the line, but developers can implement these full properties themselves in order to leverage what happens in a get accessor or a set accessor. Let me give you an example. Let's say here we have an integer property called count. If we make this a full property, which looks exactly like the snippet before, but let's say that when the count property is modified, a method is run to recalculate some value somewhere else in the application. And here you can see that inside the setter, we can add additional code to do things like trigger other logic outside of this property, validate the input values that the user provides to the user interface, or update related values in this class or even in other view models or other classes. While it can be very useful to update data from the C# view model, sometimes when you update data from the C# view model, the UI doesn't actually update. So you update the value of a property inside the C# setter, but you notice that the UI doesn't actually see that change. The reason the UI doesn't see that change is that the UI is going to identify all of its binding expressions and the values of those binding expressions when the user interface is loaded. Sometimes the user can click a button or change a value in a combo box, and the user interface is notified of that change as well, and so you can see that change. But otherwise, the UI doesn't know to reevaluate its binding properties for changes on properties in the view model. For this reason, Microsoft has developed an interface called iNotifyPropertyChanged. This interface allows you to use an event handler called PropertyChanged to notify the view anytime a property in the view model has changed. The basic way that it works is that on the PropertyChanged event handler, you just call a PropertyChanged event, and one of the arguments that goes into the PropertyChanged event is the PropertyChanged event args, and in there you put in the property name. Notice that you do not put in the property value, you just put in the name of the property. So it would be greeting here, not actually what the greeting says. The reason for this is that the UI needs to know what's the name of the property that I should reevaluate, and it'll go back to the view model and reevaluate the value of that property. Let's look at one more hands-on example where we can see how these properties can be invoked to modify data within the C# code, as well as playing around with this behavior about notifying the UI of changes in properties in the view model. For this final demonstration, we're going to add a little bit of complexity to our MVVM project, the simple project that we worked on prior in another demonstration. So to complicate the project a little bit, let's try to use something other than a basic string for our patients and our selected patient. And to do that, I'm going to create what's called a model in the model view model pattern. So I'm going to right click on the project. I'm going to add another class, and I'm going to call this patient model. I'm going to make this patient model public as well, And I'm going to add two properties to the patient model, keeping it still pretty simple. So I'm going to add a name, and I'm also going to use my prop tab and add another string for the ID. Now I'm going to change the properties in my view model to, instead of using a string, I'm going to use the patient model. Now this is going to change things a little bit when I put patient model into the list object as well as patient model into the selected patient, in that my instantiation here is no longer correct because they're no longer strings. So I'm just going to make a basic change here. I'm going to remove patient 1, patient 2, and patient 3, and instead I'm going to add 3 patient model class objects. So I'm going to add a new patient model with an ID 1111 in the name of patient 1. I will copy and paste that 2 more times to add a patient with ID 2222 and another patient 3 with ID 3333. Now, I haven't updated anything in the user interface, so with this basic change to changing the string to a patient model, let's see how our user interface behaves. Well, in the user interface, if we look at the values in the combo box and the value that gets set in the text block by consequence of having the same binding as the value to the combo box, you'll see that the values in here, they don't look very good, right? It just says WPF app1 underscore MVVM dot patient model. And that's because the UI doesn't know how to display this class object. So we have class objects that are binded to these attributes, and luckily the combo box has a nice attribute called display member path, and we're going to set the display member path to the name of the patient. Now, to help the text block as well, we can just display just the name property of our selected patient in the text block, and you'll see we've got the application working as we want it. But this is where we're going to take this a little bit further. I don't want to just see the name in the text block. I want to create a calculated value called patient name that includes both the patient name and the patient ID. So I'm going to create a separate property, and now our combo box and our text block no longer share the same property in its binding expression. So let's go back to the view model, and in the view model, we're going to create another property for the patient name. So keep in mind how you spelled patient name in the binding expression. It is very important to spell these exactly the same. But I'm going to create a public property that's going to be of type string called patient name, and I'll put my get and my set. And I'm going to run the project just to show you what you might expect is that now I can see my patient name in here, but I don't get anything in the text block. And that should not be surprising because we have a patient name property defined in the view model, but we haven't actually set the patient name property to anything. And this kind of gets into that discussion that we were having about getters and setters. So if we want to set the patient name property inside of the view model, it could be helpful to create a full property for the selected patient. And this time I'm going to use prop F tab to do that. And I'm going to create what's called a private backing field here with this underscore selected patient. And then here's my actual property that's binded to the combo box called selected patient. Now I have a get and a set, and I can actually leverage code inside of those curly braces. Let's talk a little bit about what that get and set means. If I were to type in here patient name equals my patient, that would be a set. I am setting the value of patient name. Alternatively, and just as another example in this constructor, if I were to instead maybe create a new variable, I'll call it just my patient name, and this is a string. And if I were to put the patient name on the right-hand side of the equal sign, then the patient name has to be accessed, or a get has to be called on the patient name to set my new property, right? So that's the idea behind get and set and the behavior. So when the user modifies the value of the combo box, what they're doing is they are setting the selected patient. So when the user sets the selected patient, I want the patient name to include both the selected patient.name and then perhaps in parentheses we'll put the selected patient.id, and then I'll close those parentheses. And let's actually see how this looks when we run the code, and let's see if we actually get that patient name that we expect. So here we're going to go ahead and start the application. We're going to change the patient to patient 1, and you notice that the user interface actually does not update. And this one is actually a little bit of a surprise. So why not? Well, let's do a little bit of refactoring to kind of clean this up and make it look a little bit nicer with some string interpolation instead of putting all these plus signs in here. We'll just remove some of these plus signs, wrap our variables inside of squiggly brackets, and clean this up a little bit. But let's do a little bit of debugging as well. If you remember how to debug, you're going to come over to the left side of Visual Studio and you're going to click right on this left panel here, and that's going to create a couple of debug points. I'm going to run the code, and then you'll notice when the user changes the value of the selected patient, that's when the setter is invoked. You can see at this time the patient name is null if I hover over the patient name, although the selected patient is patient 1. But if I go to the next line down, you can see that the patient name does have the format that we expect. It's just not showing up in the user interface. So to look at that again, here after the patient name is run, I now have patient 2, and again, I'm not seeing it in the user interface. And this is the key of what we want to get to. So basically, when you have a property that changes in the C# code, the user interface doesn't know. And this is why we have an interface called iNotifyPropertyChanged. That iNotifyPropertyChanged interface lives inside of the system.component model namespace, which is one of the built-in framework class libraries in the .NET framework. But to implement that interface, we have to have this property changed event handler, which I'm just going to move, down below so you can see it all the time. It doesn't matter where this is. I'm just going to move it so you can see it on top of my patient name. Now that I have this property changed, I need to be able to invoke it, right? So I need to be able to invoke it. So I'm going to make my patient name property also a full property. So now I'm going to have 2 full properties in this view model. So I'll just do prop f tab tab. I'll change the type to string. I'll do an underscore patient name, and then my capital patient name, which is the binded property to the text block. And inside the setter, now you'll see when this setter gets set as we debug this, but inside the setter, I'm going to call a method called onPropertyChanged, and I'm going to pass into it the name of the property that I want to change. And in this onPropertyChanged method, I'm going to invoke my propertyChanged event. After removing the throw new not implemented event argument, we can first check that the property change is not null, and then we can add our property changed event that takes this as this class and a new property changed event arg, which is again the name of the property. Let's add a couple of debug points to see how this works right from the beginning. So I'm going to add a debug point in the setter of the selected patient. I'm going to add another debug point in the setter of the patient name, and I'll add a final debug point in the actual property change method that I've created here. Now, when my user goes to select a new patient, the first setter is the selected patient, and that's where the patient name is set in this line here. Now, because in the wording I just used here, the patient name is set, the setter for the patient name then has to be called. So you can see the patient name is now patient 1 with the ID in parentheses. That onPropertyChange method is called from the setter of the patient name. And now you can see when I hit continue, we have the new patient name format at the very top of the screen. So let's remove the debug points and kind of see how the application behaves. And even though this is a very simple application, you can see how the change in the selected value of a single attribute or a single property can make drastic changes to the user interface. So now you can see our application is behaving. We can select a new patient. You can see the patient update here, and our application is binded correctly. So with that, take those kind of examples, think about how they work. Check out the examples on GitHub. If you want to download them, the link will be in the YouTube description. And I hope to see you in the application development with ESAPI course, where we're going to be building all sorts of fun and exciting applications.